Hello. In this video, we're going to look at the coefficient of variation, as well as try to compare how two different data sets with a mean and standard deviation given change over time. The coefficient of variation is the ratio of the standard deviation to the mean expressed as a percent. There's a little typo. The coefficient of variation is equal to the standard deviation divided by the mean times 100 to make it into a percent. It's basically just a ratio or fraction of the standard deviation to the mean. So how much do the values change compared to what their average or weighted average is? Very useful measure to compare data values of distributions in different units. So if you wanted to compare units, I don't know, let's say you wanted to compare the average fuel consumption in the US versus in, I don't know, Italy. Well, we use the imperial system in the US and we use the metric system in Italy. So it'd be very difficult to compare gallons to liters, so we'd have to have some kind of way of comparing them. So we can use the coefficient of variation, which is just a percent rather than the actual calculations of the mean and standard deviation in gallons versus mean and standard deviation in liters. It's also very useful to compare data values of distributions whose distance between their means is very large. So let's say you had two different sports teams, one of which was a professional sports team which had multi-million-dollar contracts every year, and you wanted to figure out, I don't know, what the mean of something was for the average player contracts and their, I don't know, their season record versus some amateur team who has much less average contracts, and you wanted to compare their winning records or something like that. So the difference between the means of the professional team versus the means of the amateur team would be much different. So anyway, let's look at the first example here, or the only example in this video. It says, example 3.17, a financial advisor has been studying the performance of two companies over the last year. The following approximated data shows how the stock's prices have varied during that time. So some stock for company number one has a mean average of $100 for the year and a standard deviation of $10 over that year. Whereas stock for company number two has a mean of $25 and a standard deviation of $7. Based on this performance data, we want to answer the following questions. Question A asks, which stock has a greater absolute variation? So when we're talking about the greater absolute variation, we're talking about the greater standard deviation. Again, the standard deviation is just the typical amount of change. So when we're trying to figure out how much these things vary, we're talking about the standard deviation. So stock for company number one has a larger standard deviation, so it has greater change overall. Part B says, how many shares of company number one's stocks could an investor purchase for $1,000? And part C says, how many shares of company number two's stock could an investor purchase for $1,000? So for both of these, we want to calculate how many shares a person could invest with for $1,000. So for company number one's stock, we take the $1,000, we divide it by $100, because that's how much it costs on average per share, and we see that we would get 10 shares for company number one. For company number two, we do something similar. We take the $1,000, divide it by $25, and we'll see that we can get 40 shares. I hope that makes sense. Basically what we're trying to do is just split up our investment and figure out how many shares of each company we could get for the same $1,000 investment. And the reason we want to do that is we want to compare what will happen if the stock market varied one standard deviation. Let's say that there's some type of turmoil in the markets and stocks across the board all varied by one standard deviation, whatever that means for each of those stocks. Well, how much money would be gained or lost for both investments in stock C? Well, in questions B and C. Well, for company number 1, with 10 shares that change by $10, because that's the standard deviation per share, that would be $100 difference. So if the stock market went up 1 standard deviation, the investor would make $100 on their investment. If the stock market went down, the investor would lose $100 on their investment. For company number 2, we have 40 shares with a standard deviation of $7 per share. Oh, that's bad 7. Let's make that better. So we would have a total of $280 if the stock market went up 1 standard deviation. The investor would have earned $280. If the stock market went down 1 standard deviation, the investor would have lost $280. So that's how we can kind of compare the means and the standard deviations, but we can go a little bit further. In question E, it says which stock has the greater relative variation. The relative variation is the same as the coefficient of variation. Just to recall, the coefficient of variation just says to take the standard deviation divided by the mean, multiply it by 100 to make it into a percent. So to do this, we're going to do, we'll do company number 1 first. Company number 1 would be the standard deviation of $10 over $100 times 100 would be 10%. So if the stock market changed by 1 standard deviation, it would change the investment by about 10% of whatever the original investment was. For company number 2, sorry about that, company number 2, we have a $7 standard deviation with a $25 mean price. Well, 7 over 25 is, I'm not sure. Let me grab my calculator and plug that in here. 7 divided by 25 times 100, I forgot the times 100 on the screen, would be 28. So if the stock market moved 1 standard deviation, then it would be a 28% change. So which stock is the riskier investment? Company number 2, even though it's a lower initial cost for the investor, company number 2 has a higher coefficient of variation. Therefore, it is more risky, which is not a bad thing. If anyone is invested in their retirement accounts, you know that when you make your retirement portfolio, your investment portfolio, your financial planner will ask you how risky to make it. Generally speaking, folks that are younger and investing in the stock market or investments in general will take on riskier investments at a younger age because they have less money in their accounts and more time before they get to retirement. For folks that are closer to retirement, they tend to be more conservative in their investments because they generally have more money in their accounts, so they're more concerned about losing that money in their accounts. And also there is less time to retirement to recoup any potential losses if it becomes too risky and too much is lost. Anywho, I hope you enjoyed the video. Thanks for watching.